Good afternoon, Star Trek. Welcome to 5 Simple Steps for Simplifying Your Compliance Journey with a Service Mesh. Man, I'm so excited. Sorry. Ooh. I am your host, Granville Schmidt, and I am the lucky presenter to be the last person standing between what you are really here to see. Endgame. So just sit back, relax, and enjoy the presentation. Before we get started, I wanted to point out there's one exit in the front, one exit in the back. And so at any time, if you're so excited about implementing a service mesh in production on a Friday and just can't wait till Monday, please leave gracefully, head to the nearest aisle on your left and right, and follow the lights down the stairs. I guess turn the power on the remote is a good idea. All right, our agenda today. What is this about? Who is this random guy talking to you? We're gonna have a brief security review about monolithic architectures and then the transition to microservice architectures. We're gonna go over what a service mesh is. We're gonna go over the Istio architecture, and then we're gonna learn how to leverage Istio to simplify your compliance journey utilizing a service mesh. Who am I? My name is Granville Schmidt. Friends and colleagues call me G, so please from now on, call me G. I'm currently the Site Reliability Engineering Lead at Aspen Mesh. We are a division of F5 Networks, tackling the service mesh space. And so we actually provide an enterprise distribution of Istio, as well as a cloud platform for handling all of the monitoring that you need for your production applications. Previously, I was the information security officer for a healthcare startup here in town. Before that, founded a sales software company, was the chief technology officer there, and principal architect before that. I absolutely love regulations and standards. Who in here loves regulations and standards? Yeah, you're the odd ones. No. So, regulations and standards have like this really bad taste in a lot of people's mouths. It adds all this complexity to our systems. We're doing really cool things. We're building distributed systems. We're solving, really interesting business problems. And then you hear from your security officer, your compliance officer, hey, you have to, secure all this data at rest. Like, okay, let's just put in a database, put on AWS, Azure, whatever, and just turn on encryption. It's that easy, right? Not quite. What you'll learn throughout your compliance journey as an organization is that you want to really start building this stuff into your process early on, really take feedback from the security and compliance individuals in your company and bake them into your process. If this earlier you add it on, the easier your lives are gonna be. And now we're going to discuss the monolith. Give it a second. Raise your hand if you've seen 2001: A Space Odyssey. You guys love this reference, right? All right. So our monolith from a 50,000-foot view. So we have this awesome client traffic that makes its way into a load balancer. And again, these diagrams throughout this presentation are going to be really high level because we're targeting developers, operators, security, and leaders alike to go over this. So please forgive brevity in here. So we have encrypted client traffic going in to a load balancer, and it heads into our private network where we have these monoliths. Inside of our monoliths, we have authorization code. We have authentication code. We have our, the business value code that's in there. What this piece of application infrastructure are supposed to be doing. And then we have this data storage logic that's, storing all of our data. And hopefully you have logging and perf monitoring in there as well. Your security person comes in, your compliance person comes in, it's like, we really can't be terminating traffic at the load balancer. You're like, okay, we got this. You're like, we'll grab some certificates, we'll put them in each one of our services, bam, we have end-to-end encryption from client entering load balancer to our monolithic services. This is fine and dandy, right? Then we have this point in time that our organizations love. We call this the split, or the breakup, whatever you want to really call this. It's when we take this or this and turn it into this. So again, we have our encrypted client traffic. It enters into a reverse proxy, followed by the destination service it is going to. This is where life gets really interesting. Instead of just having these monolithic services where we have all of our authentication, authorization, business logic, we have this brilliant thing. We're speeding up delivery. We are putting all these services. We have independent, isolated teams that are providing value to the organization. So then we end up with this. This is manageable, right? No, we have logging, we have perf monitoring, but how are you monitoring and watching this? Keep this in mind. Compliance and security come knocking on your door. Hey, you remember when we asked you to add this back in a while ago? Well, auditor said that you're missing this now. It's like, well, no excuse. We have to achieve this. This is hard. I want all of you to think about how you currently implement something like this or how you would implement something like this. We talk about, maybe one option is we go out to our certificate authority and we start baking certificates. We're like certificate A, certificate B, certificate C, and we start adding it to all these services, right? And then, 90 days later, security and compliance comes knocking at the door, and they're like, hey, have you guys rotated these? And you're like, what? And you're like, yeah, have you rotated them? So now you have to no. So we go back to our certificate authority. We're like, bake certificate A, bake certificate B. And we start adding them all back in. And this is a very manual process. It's no fun, right? We're here to be adding value to the organization. And what we see are these blockers, right? We start complaining. And if you complain loud enough, you go back to this. And you're without compliance. And it's not until auditing time that things are added back in, and your team's velocity is starting to increase. The rise of the service mesh. Once upon a time, a service mesh was born. So some of the key concepts is, what is a service mesh? So a service mesh is a thin piece of infrastructure that actually provides monitoring, security, resiliency to all of your microservices. So if we go back to, let's go back to this one real fast. If I can have a volunteer, how do we currently log this? Anyone? If no volunteers, I will volunteer someone. Just kidding. App Insights, that's good. App Insights. Anything else? Okay. So when you're going through and you're debugging your microservice code, how easy is it for you to say, go from customer complaint, hey, this took 8 milliseconds, or hey, we're receiving errors all the time, to actually finding the root cause? Without proper instrumentation, this could be hours, days. Heck, I've never found sometimes. I'm like, hey, oh, I think it was this service. Just randomly picking things. So why would you use a service mesh? Well, a service mesh helps you solve these types of problems. We want to move fast. We want to provide value to our organization. With a service mesh, we're able to not only secure our microservices, we're able to monitor and help resiliency of them. For instance, we've heard of circuit breakers, retry logic, mutual TLS. If you add in these concepts into your code, you are plaguing your code, your application business value code, with these more security-focused, resiliency-focused features instead of actually working on what your business team wants you to work on. Not to mention, it's sometimes just not fun. Most of the time, we get it wrong, and that's okay. Not everyone's security or compliance engineers. But a service mesh helps alleviate those problems. How do you use a service mesh? Well, there's not just one service mesh. There are multiple, and today I'm going to be talking to you about Istio. Along came Istio. So if we were going to take 60 seconds to really summarize what Istio is, it's an open platform to connect, manage, and secure your microservices. It was created open source by Google, IBM, and Lyft. Today, it is now production ready. It has 16.9 thousand stars on GitHub and 2.7 thousand forks as well. All right, this is the fun stuff. Don't worry, we'll get this covered. So, Istio is made up of the concept of both a control plane and a data plane. Think about your control plane as all of the services that make up Istio that actually help bring all that value that we discussed. And your data plane is all the data that is transitioning through the network that your business applications represent, right? So, for instance, down here we have service A, and then service B and service C. Each one of these are written in a different language with a different web server in between. Service A may need to call into service C, service B may need to call service A. And if we start thinking about what we were talking about before, how do you secure service B to service A? Again, we may bake in a certificate and the both plaguing code, plaguing configuration. And every time that you need to update that, you have to update your services and now they're redeploy. And it may take down your production application if you don't have resiliency baked in. The data plane of Istio resides with these beautiful pieces of code called Envoy. Envoy is another open source project created by Matt Klein at Lyft. It's built in C++, blah, 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 but what really matters to this conversation is that it is the entry point and exit point for all of your services. And what this provides to you is all the telemetry, all the security features that you no longer need to bake into your code. You may not need to, no longer have to bake in those libraries, update libraries. It all happens right here and transparently. Next up, we have Pilot. So Pilot is part of the Istio control plane. It actually provides all the config data. So to really help a service mesh function well, we need to actually understand what is all encompassed in our cluster, or clusters if you're federating clusters. Pilot's job is to know about all of this. It gets updates from whatever is orchestrating your cluster and provides all that data down to your Envoy proxies at each one of your services. Mixer provides the policy and telemetry inside of Istio. So what it allows you to do is understand what is actually happening, how many calls, what is the time for calls, and also providing RBAC authentication and other policies that help you govern how your microservices operate. Citadel, something I absolutely love. So Citadel, think about it as your internal cluster CA. It actually helps bake and build and bake all of these certificates that get distributed to each one of these Envoy proxies. Galley is a very important piece of Istio. It helps verify all the configuration pieces, and then the sidecar injector. So can I get a raise of hands? Who has used Kubernetes? Awesome. How many people love Kubernetes? Yeah, all right. So to put this in perspective, so Istio sidecar injector, if we're talking about Kubernetes, what it will do is it will watch your deployments, and when a deployment is being made, it will actually add in the Envoy proxy as a inside of your pod. Sorry, no worries. It's going to add inside of your pod and actually on the fly. So when we think about developers and the workflow around that, we no longer think about, oh, how do we add this application code, this tracing code, this monitoring code. You shouldn't have to worry about it at all. If you're web server, if you're accepting requests, then that's all that's needed. It needs to have an open port. It's accepting web requests, gRPC requests, TCP requests, doesn't matter. If it accepts it, Envoy will go in front and actually start adding those metrics and security features for you. So how do I leverage Istio to help address my security and compliance requirements? Before we get started with that, I really want to take a moment to understand compliance as a whole. What do all of these regulations and standards boil down to? If you take a look across all of them, they'll include things like authentication. How do you verify the identity of the actor that is making the request? Authorization. How do you verify that the actor is allowed to perform the action that they are making? Accounting. What mechanisms do you have in place to ensure that, that you're actually keeping track of every action that was performed by both a user or a service? Data integrity. Protecting data from being altered. This is key, fundamental to pretty much all regulations and standards out there. Some of these requirements, we're going to go right back. Sorry. Some of these requirements, as you may know, may not have any direct technical security requirements in them. But you know what they fundamentally have? They have a requirement to have a sound risk management strategy. And this is where it gets iffy now. So the sound risk management is open to interpretation. Given all the security breaches that happen on a day-to-day, you know them all, we're aware of them. You need to start taking these into account. So when it comes time to auditors that say, do you have a sound risk management process? That's where it gets interesting, is because with all the breaches, there's new requirements that are built. So when we talk about have you performed your due diligence? Did you encrypt the data at rest? Did you encrypt the data in transit? Did you perform the correct authentication and authorization at the right points? And even better, how do you prove this? A lot of us, including myself in the past, we've built these systems, and I'm like, yeah, look, this thing is secure. That's great. How do you prove it? So, back up out of here. So the accounting mechanism inside of this is key, right? So it's not about if it's secure, it's can you prove that it is secure? Story time. How many people in here have done an escape room? All right. How many of you love escape rooms? All right. Well, so first off, I want to clarify. Anyone in here that knows me knows that when I commit to something, I go all in. So 3 weeks ago, I was sitting down with my lovely girlfriend that's in the crowd here, and we were watching this new escape room movie. And I was like, wow, this is really intense. Like, this is cool. Like, it's kind of like horror film-esque, like trying to escape these rooms. It's like, this looks fun. So while we're sitting there, we took a quick break, and I'm like, click. All right, we're doing an escape room at 4 o'clock this afternoon. It was awesome. The experience was really interesting. For all of you that haven't done it, you're trapped in this room with the people you came with, sometimes with additional people, and you have 60 minutes to get out of it. And because, again, when I start doing something, I go all in. Next day, we did 3 of them. The following weekend, we did 4 in one day. And I really enjoy these. It's really cool being an engineer because we try to engineer our way out of boxes all the time. And this is a great example of you're stuck in a box. You have 60 minutes to escape. Use your brain, use your team, and teamwork is key. Let me tell you, teamwork is key. There are many times that, throughout my engineering career where I'm building something, I'm like, I think I have the answer to this. In fact, I know I have the answer to this. Let me tell you, I never actually had the answer to it. Thankfully, I had an awesome team behind me. And the same thing goes to the escape rooms. But one of my favorite things I took out of this experience was like the creative side of this. What it all took to actually build these experiences. Some of them are immersive, really, really immersive. I did one where we were actually putting together a time machine. And on a wall, there's chemicals that you had to put in different orders and line things up. It was just really cool. I don't want to ruin it for you. Come out to Colorado, and I'll hand you the list. But because of that, I want to create escape rooms. And, they're kind of expensive. They're kind of hard to put together. But I was like, you know what? I'm going to Star Trek in a few weeks, and I'm going to give a presentation. So I figured, let's give it a shot. Your mission, Star Trek, should you choose to accept it, is to leverage Istio and the provided clues to implement portions of the common technical requirements found in standards and regulations for the following services without writing code. This message will be removed in 10 seconds, 15 seconds. All right, I'm done counting, sorry. All right. Here's some top secret plans for the universe's most advanced patient check-in application. Check this baby out. We have a check-in service, we have a patient service, and we have an admin service. Looking pretty advanced, right? Check out these HTTP endpoints. We have a post check-in. We have all the CRUD for the patient. So we can add a patient, we can get a patient, we can update a patient, and we can delete a patient. That sounds fun, right? Admin service, get employees, post employees, put employees, delete. Oh, again, delete employees. We can remove employees from a hospital. I don't know, this is sounding kind of tempting. This is my security side coming out, right? Do we have a firm understanding of this? All right, good. Here is your first clue. All right. Do I have any takers? What are we going to be doing first? All right. Let's take a moment. It is 3:53 in the afternoon. I get it. We've all been in sessions all day. And then there's this guy talking about security and compliance at the end of the day. I know. Come on. Endgame's coming soon. If I get some, what was that? All HTTP endpoints. I like it. What does that mean? Transmitted in plain text. Do we have any other takers on what we should do with this? I like it. Encrypt all the things. That is correct. First up, we are going to encrypt traffic and ensure non-repudiation for requests. It's a mouthful. I get it. So we have the check-in service. We have the patient service. Who in here, by show of hands, encrypts their traffic microservice to microservice? All right. That's actually more hands than I thought, and there was only 2 in the room. How many of you have fun encrypting your microservices? All right. So we're going to achieve this using what's known as mutual TLS. If you're familiar with mutual TLS, it's where both sides, without getting technical here, both sides know about each other and they agree to talk to each other. But what this would mean, if we're not talking about a service mesh such as Istio, we are going to go to our CA, we're going to bake a certificate for check-in service A, make sure it knows about check-in service B, the patient service. We're going to create a certificate for the patient service that also knows about the check-in service. This is great, right? So we bake those two, we put them in there, we redeploy our services, fine and dandy. We have end-to-end encryption. Again, 90 days goes by, kind of a pain. So what Istio allows us to do is if we go back up to this, we inject these Envoy proxies, right, that live right next to our application code. And so what that allows us to do is we're able to handle all of that logic. How do you get these certificates? How do you deploy them to your services? How do you ensure that it is updated in real time for what service can talk to which service? And so the proxy injects a certificate that comes from Citadel. And guess what? When you redeploy this check-in service, it gets another certificate. What if the check-in service needs to know about another service down here? If you're doing this manually, you're going to have to go bake another one. But instead of just adding it to here, maybe it needs to call here as well. You're going to have to update all of these again. Because just because you're adding a service here, this one needs to know about this one and this certificate. So instead of baking that yourself, Istio does that for you automatically. So if you've ever done microservices, how many of you have ever used bearer tokens as your service-to-service authentication mechanism? Yeah, I did too. It's actually an anti-pattern. Why? So the bearer tokens are actually, they can be stolen from the source destination, and they can actually be replayed service to service. And what that allows you to do is that you actually just undermine everything. Again, we're trying to achieve non-repudiation for these requests, which means without a doubt, actor A called B. And if they can be replayed, you no longer can actually ensure non-repudiation. Here is clue number 2. Trust is key in relationships, not for service-to-service communication. All right, we have some new faces in the crowd. Thank you for joining. Just to fill you in, we have clues on the screen, and the idea is that we're going to use these clues for implementing the technical controls. Do I have any takers on what this means? All right, guys, zero trust, that is correct. Remember, participation is key because we have 60 minutes. If we don't get out of here, I guess there's no end game. Just kidding. Yeah, so trust is trust no service, right? So we don't want to give trust to anyone. Just because we've authenticated them doesn't mean that we trust them, right? So if we go back up to this one, we have the check-in service. It can talk to patients, but maybe the check-in service shouldn't talk to everything in the patient service, right? So if we go right back up to this beautiful, what do we know about the patient service? It has all of these methods. Should the check-in service really be able to delete a patient? This sounds fun, but likely no, right? We need to enable service-to-service authorization. All right, so those of you that have raised your hands about authenticating service-to-service, how many of you actually authorize each service-to-service? Yeah, this gets really, really hard fast. So let's take, for example, this check-in service. The check-in service makes a GET request to the patient service, It needs to get a patient before it does whatever operation it needs to do inside of its own code. And the admin service needs to, looks like it's, it's creating one. That is the wrong error status code there. That should be a 201. It is creating a patient, and it's updating a patient. That's all fine and dandy. But this check-in service, I'm not sure how this happened. That's why we have code reviews. But it tried to issue a delete request on employees against the admin service. Look, we shouldn't trust. And if we do, we shouldn't trust everything. If we're going to trust, we need to verify it, right? One of my favorite things I learned from someone at my past employer. We need to trust and verify. So just because we wrote the code doesn't mean we should trust it, right? The whole concept behind microservices is that we have these independent teams that are able to work, on their own. They get handed these contracts from these other teams saying, hey, this service does A, B, and C. Here's our SLOs that stand behind it. Let us know if you have any issues, right? So another team in your company should be able to say, hey, I know there's this amazing patient service out there that I can use to get all the patients in our application. And then they should be able to build their service on top of it, right? Like this check-in. Beforehand, this company was likely just, no, sorry. This company likely just, let's just say they index patients. Kind of a weird company, but they just index patients. I'm sure it exists. Then this other team gets handed these business requirements like, hey, we're now turning into a hospital. We need to start checking in patients. So without having to talk to the other team, they should be able to look at this API contract and start talking to it, right? That's fine and dandy, but when we talk about security and compliance, we need to make sure, without a doubt, that we understand what the communication looks like in our infrastructures. We need to make sure that it is documented somewhere. Documenting and adding it as a change request somewhere else, it's not fun, right? The idea is that we're trying to move faster, not slower. My approach when we take security is that we need to ingrain it into the process and use it to accelerate what we are working on. And so what we can do is with Istio, we can actually add RBAC into our services. So we can add RBAC on things like what service can talk to what service. We can go down to the method level. So if we're talking about HTTP, we can say this endpoint can be hit by this actor, this service, this user. If we're talking about gRPC, we can say that the check-in service can talk to the patient service at this one method. And so if we look at doing this in code, this gets really complicated. So it relies heavily on the fact that we can provide non-repudiation for requests, right? So we have to have one, solid authentication. In microservice world, you no longer can rely on the fact that you have these RPC calls inside on the same node even, You can no longer rely that this transmission is not being intercepted and manipulated. So with it, you have to ensure that you have one, end-to-end encryption around those services. You have strong identities in there. You ensure that that certificate can only ever be had by the check-in service. The patient service certificate can only ever live in the patient service. Istio bakes that in. If we go back up to If we go back up to here, so Istio does this really amazing thing. So imagine that these are on a node, right? Istio has this agent that lives there that actually will communicate with will take Envoy requests saying, hey, this new service is there. I have this one spinning up. I need to get a certificate for it. It will actually communicate directly down to the node, which goes up to Citadel to get the certificate. And that all happens in memory. That configuration, that certificate, never goes through an engineer's hand. You can provide without a doubt that service C is service C. I hate going back through that slide because I said it would be removed in 15 seconds. All right, Clue number 3. If a user performed an action and it wasn't logged, did it really happen? All right, come on. Give me some chuckles for that one, please. All right, thank you, thank you. So if we can, any takers on this one, what do we need to do? What was that? What was that? All right, there we go. I like this. All right, this is one of my absolute favorite things about a service mesh. Who in here logs every request made to their microservice? Oh. How do you keep track what happened? How do you provide the auditors that information? It's hard, I get it. So we're going to start collecting access logs and distributed traces. This is where it gets really, really fun. All right, so as we mentioned, we have this amazing Envoy sidecar proxy thing that lives right next to our patient service and right next to our check-in service. These two, again, are encrypted, talking, but the Envoy, this thing's amazing. Every request going in, we can trace. What does that mean? So tracing is this amazing concept in distributed architectures. In fact, one of my friends that gave a talk earlier, Michael Meadows, he gave a talk in distributed architectures, and his quote is, "The problem that nobody thinks about until it's too late. How do you actually monitor these interactions?" So one option is, in our code, we can actually start, at our web server, we can grab these requests, start linking them, build out these awesome, models. We can talk about hierarchies, what called who, blah, blah, blah. But that's a lot of work. Is it providing value to your business? Maybe. Are there other tools on the market? Absolutely. That's what we have Istio for. So what happens is this Envoy will take the request, and it will add it to Jaeger. So Jaeger is a distributed traces application. Anyone here use Jaeger? Oh my, you will after today. So what happens is we need to understand the call chain, right? We need to understand that service A called service B, that then called service C, that then made a awesome, amazing request up to another Dynamo instance in Amazon or another RDS instance or whatever it might be. How do you go about tracing that? Envoy does it. Remember, every request goes through the proxy, both in and out. So what happens is when any request goes in, it actually adds to it. So it knows that service A called service B, and then it keeps that history, and it writes it to Jaeger. When service B then eventually calls service C, adds it to Jaeger. When service C actually calls into the database instance, it adds it to Jaeger. And you get out this amazing, beautiful graph right here. I had to blur these out. This is out of my production system. And we have sometimes, 1,000 different calls that happen and responds in a few hundred milliseconds. But what's amazing is that anytime we have a production issue, I can drill down to the exact service at the exact time that it happened. I can get the error code. I can get the log. I understand what happened in this chain that made it end up where it's at. We also have the concept, so Envoy has access logs. So not only do we have distributed traces, we can actually provide non-reputable access logs about what happened. So we have this amazing example up here. This is an Envoy log from where we are getting a patient, and it's responded back with a 200, where it came from, what happened, what port it was on, and all that's automatically available for you. So again, there's no configuration needed in your code. Step 4, control outbound data before it controls you. All right. I can tell everyone's really awake right now. I'm gonna give you guys a hint on this one. We need to control egress. So when we talk about our services, we get really, really excited. You know, I'm an engineer. I get excited by shiny objects. I'm like, hey, there's this new database technology I can use over here. I want to use it. Security compliance isn't normally a thought that a lot of engineers have. And so when we talk about HIPAA, you know, HIPAA has a lot of interesting requirements around it about like where that data can be stored. And so you have concepts of HIPAA compliant databases, non-HIPAA compliant databases. And you know, we have to ensure that you know, individual teams that have the autonomy to do what they need to do also don't accidentally leak our data into a service that could be you know, considered an infraction. So Istio provides what's known as egress control. Your organizations may already have this requirement. You may have X number of nodes, X number of places that a request has to go to before it makes its way outbound to the internet. And it's this way of, you know, verifying that, you know, there's no intellectual property there, there's no confidential information that shouldn't be exposed to the internet. And so with Istio egress control, you enable your teams to actually move fast by allowing them to actually configure the outbound data. So what you will normally do in this case is you have your security and compliance team. You're like, you can talk to Dynamo instances in the US West 2 region. You can talk to this RDS service in the US West 2 region. That's it. This is all we verified right now that is HIPAA compliant. So with Istio, you can add those into your egress control and verify it. So if this patient service that magically got deployed by a brand new team and they get it deployed in production and they try to start talking to this non-HIPAA compliant database, it's just going to error out. And luckily, because you also have this, you're going to see what happened, right? You're now able to get complete visibility in, hey, this was being blocked and why. This is step 4, right? I promised you 5 steps. Here's your next clue. Life is a journey. Any takers on this one? Please? One hand. All right, all right. Step 5, replace me. Crap, I forgot to finish the stack. Actually, this is almost partly true. I thought about what the 5 steps were going to be for this, and I had multiple things that were competing for this last one, and inside I felt like this was wrong. It is not fair for me to give you 5 simple steps to simplifying your compliance journey. It's not that simple. It really isn't. Just like life. No, go back. No. Just like life. Compliance is a journey. There is no one and done for compliance. In fact, here's one of the things that I live by. Secure does not equal compliant, and compliant does not equal secure. The reason is we oftentimes start, building out these amazing architectures that we're like, this is super secure. Compliance comes in, how do you prove it, right? If you can't prove it, is it really there? Kind of like the user, performing whatever action. If it wasn't logged, did it really happen? And compliant does not equal secure. So this one is critical. Please, please, please. We as individuals in engineering organizations, we need to really realize this. Oftentimes we have security, we have compliance, they have these checklists. They're like, hey, just implement A, B, and C and we're good. No. Those checklists are a framework. It is just by implementing A, B, and C, it does not mean that you are secure. You need to make sure that you have security, you have compliance, and you bake them both into your process. And by doing so, I promise you, you will accelerate your long-term velocity. Thank you.